C++ classes can have member functions that act as methods for the class. Here I have a working copy of working.cpp from chapter 4 of the exercise files. Let's start by creating a simple class with one data member. So there we have our one data member, and by default, data members in a class are of private scope. That means that they can be accessed from functions that are part of the class, but they cannot be directly accessed from outside of the class. So for this purpose, we create public member functions, and we use these public member functions to access the data in the class. So these public member functions are often called accessors or sometimes setters and getters. So we'll start with a setter, which would look like this, and then we'll write a getter, which looks like this. And now I'll just come down here and I'll create an instance of our class, which is called an object, and I'll use the setter to give it a value, and then we'll use a getter to read the value like this. And now I'll go ahead and build and run, and you can see that it says the value is 42. So now we have a simple class with a setter and a getter and one data member. Now it's considered best practice to separate the interface from the implementation. This is done by declaring function members in the class definition and defining the function members later. And so these function member definitions actually have the code, and it's considered best practice to take the code out of here and to do the actual function definition. So these now become function declarations, and to do the definitions outside of the class, usually in a separate file. There's usually 3 files involved. One has the class definition, and that's usually in a header file. And one has the function definitions, and that's usually in a code file, a .cpp file. And then wherever you use the code, that's in a separate file as well. Here, for example, with my main. For our purposes, we're putting it all in one file because that makes it easier to teach and learn. But in practice, you'll often see it in 3 files, and I'll show you some examples of that later in the course. But for now, let's go ahead and define our functions. And this is done like this. I say void, and then I name the function setValue, but I actually have to put a : before it, the class name with 2 colons, so that the compiler knows that this is actually part of this class. And I need the full signature here. And I put the code in and I say IA equals A. And I'll do the same for the get value, which would look like this. And now we have our setters and getters separate from the class definition. And when I build and run, you see we get exactly the same result. Now, there is one more important detail that we need to realize. This actually won't work with an object that's declared as const. So if I say const A, and I'll name this one B, and assign A to it, and then I'll leave the set value there for A, but if I use B for a get value, you'll notice that I get an error that says member function get value not viable, function is not marked const. So the argument has a type const A, but the function is not marked const. So what that means is that this getter is not what's called const safe. Even though it doesn't actually change anything in the class, you need to declare it as being const safe by putting const there and again const here in the function signature. So this actually goes after the parentheses in the function signature, and that says that this particular method is const safe. So now that I've defined them as const safe, I can use it with a const variable. So B is now an object of type const A, meaning that it cannot be modified. And so any method that's called on a const object must be const safe. A const safe method cannot modify any of its data members. And so, for example, if inside of here I tried to change the value of IA, you'll notice that when I try to build and run this, I get an error that says read-only variable is not assignable. That's because this method is defined as const safe. Likewise, if I come down here and I try to run set value on B, which is declared as const safe, you notice I also get an error because the setter is not const safe, and it can't be because it actually changes a value. On the other hand, the getter can be used either with the const or the non-const version of get value. So it says unused variable b, and that's fine because we're not actually using it. But you see that this works fine. We can use get value either with a const or a non-const object. Now here's the really interesting thing. I can have two versions of get value, one of them const safe and one of them not const safe. And what happens here is really kind of interesting, and it can be useful in some circumstances. So here's our non-const version and our const version. And just so we know which one's being called, I'm going to put in a little puts. So I'll call this the mutable getter, because mutable is the opposite of const, which is sometimes called immutable. And this is the const version. And now I'm going to have two of these calls to the getter. One of them I'll call an A, which is the mutable version of the object, and one of them I'll call an B, which is the immutable const version. And you'll notice that these two different getters are called. The mutable getter is called for the first one, and the const getter is called for the second one. So you can actually have two versions of the same method that are only distinguished in their signature by whether or not they're const safe. And this can be really useful at times. So member functions are what make object-oriented programming possible. As we go through the rest of the chapter, you'll see that most of the other features of C++ objects are based on the ability to create member functions.